Okay, so till now we have seen how EDA is important for any kind of machine learning project. So before model building, we need to do feature selection, data pre-processing, and EDA to understand the overall data and problem statement. So in last session, we have seen the how BMI, occupation, age is important factor while predicting the sleep disorder. Now we will build a model, the machine learning model using Scikit-learn, and then we will compare the two models and we will select the one model which is giving a good accuracy. So let's start with the data splitting. Okay, so to split the data we generally use train test split, and in machine learning we split the data in 80-20%. So 80% will be your training data, 20% will be your test data. But while splitting the data, you need to make sure that you separate this dependent variable and individual variable. Okay, so these are my independent variable. Like if you just include sleep disorder, exclude sleep disorder, rest of the variable will be your independent variable. So in trend test split, you can pass, or else what you can do, create X variable and copy this particular part for simplicity, create it in like pass that in X variable. So from data frame, we will drop the sleep disorder column and we will take only one, like we will take rest of the column in X variable, and X is equals to 1. Okay, then we will also create one variable Y, and from data frame we will select only one column, DF sleep disorder. Okay, so we have Y variable and X variable. Now see, X is capital, Y is small. The reason is X is multi-dimensional data, means two dimension, rows and columns. But Y is a single dimensional series data, means we have only one single column. So that is the reason we create variable in such a way to identify that this is the matrix and this is the series column. So based on capital and small, you can differentiate that thing. So I have created in my dependent variable sleep disorder using Y variable and independent variable using X variable. For that, I will simply drop sleep disorder column from the data frame. And now I will just simply pass capital X, and then instead of this DF, I will pass Y. So I want to create a test size of 0.3, means 70% will be kept as a training data, remaining 30 will be test data. Random state equal to 42 means we need to get the repeated output. So let's say if you are running this code again, then you will get same set of training and test data. So what train test split will do, it will randomly pick a few records from data frame and it will store that into the training data, and remaining 30% records will store it in the test data. So we have created X train, X test, Y train, Y test. So let's execute this part, and whenever you execute this part, you need to make sure that the shape of the splitted data is proper. So you can just print X train dot shape and then print Y train dot shape, then print the test part, print X capital X, capital X test dot shape, and then again print Y test dot shape and check the shape of the data frame. And also you can print the entire data frame shape. So print df dot shape. Now I will tell you how to read this thing. So this df dot shape indicate that we have total 374 records and 13 column, out of which we are using X train variable with 261 record. So we have splitted 375 record into train and test. So 80% means 261 record is in train variable and 12 is a column because we have removed the dependent variable, and Y train is nothing but a dependent variable for train data. So that's why this series object have only 261 values. It does not contain any other column, just a single column. So that's why we only have one number, 261, and it is matching with the test train column. Then similarly for X test data also we have 113 rows, means 30% record from the entire data set, and total 12 independent variable and 113 labels for your test data. So we will use this data for training the model, and we will use this data for evaluating the model performance. Okay, so let's print x underscore head dot. So this is our train data. Now you can see the index location is changed, 19, 357, 79. That this is because when you split the data into train and test, it will pick random numbers, random row from entire data set, so that the pattern will change. So if you see that in the dependent variable, the pattern was like, first all the records are related to 0, then 1, and then 2. But when we split the data into train test split, it will shuffle the records randomly, so that model will generalize on all samples of data. So now we have xtrain dot head. So once we are done with the data splitting, we need to process the data using standard scalar. So we will use standard scalar. You can use min max scalar also. So there are two options, standard scalar, min max scalar. Both options are used to convert the data into fixed range. The reason is to remove that dependency or biasness towards higher variable. For example, let's say I have one variable salary and one variable age. So if you see the nature of age variable, which is ranging from 0 to 100, if the age value is 135, then it's a wrong value. It is not the outlier, but 135 age is not possible. And if you see the salary value, so salary is ranging from 10,000 to millions also. So there is no fixed limit for the salary. So when we compare salary and age variable and pass that to the model, then model will think that salary has very high value. So, and this thing, age value does not have that much magnitude. So model will shift towards salary value. So it will be biased towards salary value, and it will give more importance to the salary value compared to age variable. But for problem statement, age and salary both are equally responsible. So we need to reduce that biasness towards higher value. So what we will do, we will use scalar object like standard scalar on min max, and we will convert salary into range of 0 to 1, age in the range of 0 to 1. So both the variable will be in the same magnitude, and for that we can use standard scalar. So in standard scalar, the range will be -3 to +3, and in min max the range will be 0 to 1. So now from Scikit-learn we need to import the pre-processing import standard scalar package, create a scalar object which will convert the numeric data into a proper range. And whenever we fit the standard scalar object, we always need to fit the scalar object on train data, not on test data. Because when you fit the scalar object on the entire data, and then when you split the data, then you will face the data leakage problem. So that's why in machine learning, we always split the data first, and on train part, we train the scalar object. Once the scalar object identify the entire pattern from the train part, then we transform the train data as well as test data. So in this way, we did not pass the train information to the test data part, and that's how we can avoid the data leakage problem in machine learning. Okay, so first create the scalar object and then fit the train data on scalar object. Once that is done, then you can transform the train data as well as test data. So now we have xtrain scale and xtest scale. So let's execute this part. Now if I print xtrain underscore scale, so scale data will be in a numpy array because it is much more faster compared to data frame. So that's why it is highly recommended to use numpy data frame only, like numpy format, array format for model training, because it is much faster than the data frame and array. Now here you can see xtrain scale contain values -1.0, -10 something. So all the data has been transformed into a proper -3 to +3 scale. you can see the shape 261, 12. So 261 rows and 12 columns. Okay. Now we will pass this data to the model. So whenever you build a machine learning model, you need to pass the raw data to the pre-processing part. Pre-processing part will convert that raw data into numeric feature, and then numeric feature will be passed to the model training. Then once the model is trained, then we will evaluate the model performance. So till now we have completed the data pre-processing part. Now we'll move on to the model building. So first model we will build a decision tree classifier. So it's up to you, you can choose any kind of machine learning model. So first we'll build decision tree model and we will evaluate the performance of the decision tree model. So I have imported sklearn.tree. So decision tree classifier belongs to tree family. So that's why we need to import it from tree classifier. So decision tree classifier, because it's a classification problem. So import the decision tree model first. Okay, now the model has imported and we are not passing any hyperparameter. If you want, you can pass that as well. You can just press Shift tab, check all the hyperparameters present inside this doc string. You can read the meaning of each hyperparameter, like what is the meaning of max depth, what is the meaning of min sample split, and you can set the value accordingly. But it's a first iteration. So without any hyperparameter tuning, we will build a normal vanilla model. Okay, so I have created a decision tree model like object. Now let's fit the model on scale data. So decision tree dot fit. So dot fit function will take your training data and y train data and it will train on this particular data. So here we have trained the model on x train, scale and y train. Let's calculate the accuracy of this decision tree model. So for that you can use dt.score. And it will return the training accuracy. So the accuracy of the model, like training accuracy, is 93%. Let's pass the prediction. So dt.predict function will return the prediction, but we will calculate the prediction on test data, not on train data, because the test data is the data which model have not seen yet. So now we will pass the test data and we will calculate the prediction from the decision tree model. Okay, so we got the prediction like 11000110. Okay, now we will compare this decision tree model prediction with actual ground truth value. So for that we will use confusion matrix. So from sklearn import confusion matrix, and inside the confusion matrix we will pass y test, which is our ground truth, decision tree prediction value which we have predicted from the model, and let's pass that inside the heat map function and let's see what is the output. So this is the output that we got from the decision tree algorithm. So 20, 59, 19, these are our correct prediction. So if you add 20 plus 59 plus 19 will be the correct prediction, and rest of the 3, 4, 4, 3, 2, 6, 0 is the wrong prediction. Okay. Now if you want few more clear picture, you can go for classification report. So for that you can just run this part. So let's import the classification report from sklearn.metrics import classification report. So you can directly copy this function and paste it here, and with confusion matrix you can import accuracy score and then classification report, and inside the classification report I can simply pass, let me copy this part again, paste it here, and white red. Okay, I just need to replace classification report with confusion matrix, and let's execute this part. Okay, we cannot use heat map on confusion matrix classification report, so I will simply replace with print function. Let me remove this part. Now let's print the classification report as well as accuracy score. Now instead of this I will just simply copy accuracy score. Now here we can see there are three categories, 0, 1, 2, and we have precision recall for each category. 0 belongs to none, then sleep apnea, then insomnia. Okay, so 074 precision is for 0 category, then recall 083 and F1 score. So basically we can see F1 score for each category because that will be a proper metric. Okay, now support indicate how many records present for that particular category. So for 0 category we have 24 record, for 1 category we have 62 record, and for 2 category we have 27 record. So this is little bit imbalanced data, but if you see the F1 score, which is a balance accuracy score for based on precision and recall, you can focus on F1 score, which is kind of a balance. So 0.78, 0.93, 0.79. So and the overall accuracy is 0.86. So we can conclude that the model is giving a good prediction but not the accurate one. Okay, we can check that using distribution plot as well. Okay, okay, classification report we have created, so let me delete this part. So let's plot this thing. So SNS means Seaborn library. This plot here we will pass y test value and histogram will be false, color equal to red, and then deep red value distribution plot. So basically I am plotting two distribution, one for ypred, which is our ground truth, and one for predicted value. So let's create this plot. Now here you can see the actual curve. So this blue line represent that the predicted value, and red line represented the actual value. Now the decision tree is following the pattern of the predicted value, but still you can see the gap. Like for few cases, the decision tree model is not able to predict the exact value. It is following the pattern but not the exact value. So using decision tree model, we got some accuracy of some 86% overall performance on test data set. F1 score is not good but not so bad, like 78, 79. So approximate 80-85% accuracy because support was very low. Okay, and the total error is 2 plus 2, this will be 4, then 8, 16, 8 and then 12 and then 15. So total we have 15 error. Now after decision tree, pick any other model. Now we will see random forest also, and build one model on that, and then compare the two model and see whether the model performance is increased or not, and which model is giving a good accuracy. So till now we have built a decision tree, we evaluated the decision tree model's performance, and the accuracy is quite good, not too good, but it is giving a decent performance. Now in the next part we will build the next algorithm.